Maximum voltage in a generator. Flux versus Lorentz force law. This is just a nice simple little thing that we're going to look at here. And of course we have to draw the generator again. North, south. And again we've got our spinning loop. And what I just wanted to draw your attention to is if this baby's spinning, in that horizontal point, we already discussed just in our video when we were looking at the voltage in a generator that is maximum when the coil's in the horizontal position. If we think about the electrons in here, then their velocity perpendicular to the field is maximum in this position. So we would absolutely expect there to be the maximum force on them from the Lorentz force law, and thus to get the maximum voltage. But from a flux point of view, this coil is spinning, and from your Faraday's law you've said that E is equal to minus d flux over dt. So the rate of change of the flux over dt is maximum in that horizontal position, compared to the fact that when the coil is vertical between the two fields, it's moving at the same speed, but the rate of change of the area is slower at this point, is at its minimum, than when it's horizontal, when it's at the vertical compared to the horizontal. So when it's at that position, the rate of change of the area is greatest. And this is a calculus thing that I'm sure you're reasonably aware of. So that coil can be characterized, the flux can be characterized by PA, and A can be characterized by the area of the coil through which the flux is passing, which in this case is, the area is 0, in this case it's maximum, but that's not what we're interested in with voltage. We're interested in the rate of change, and it's interesting that the rate of change is actually at its greatest when it's in the middle there. So although the flux is at 0, so if we draw our flux curve as a sine graph, we get a negative cos graph. So that's our flux graph, and that's our voltage graph. Let me just bring that up again. So when the actual flux, or when the flux is actually at 0, that's when we get our maximum voltage. And that's to do with the fact that when the flux is, when it's passing through this point, that's the maximum rate of change of the area of that coil. So we could characterize this just by a sine graph, which is what we've done with the flux, but now we're taking, so if we're taking the area that way, we'll do that in another video. I just wanted you to see that the actual Lorentz force law predicts the maximum voltage, and so does the rate of change of the flux. Both give us the same answer, maximum voltage, horizontal position. I'll do, there'll be another little video where I actually talk about how we get a formula for the voltage for the generator from this formula here. We've already done it from the Lorentz force law.